Okay, welcome everybody. Welcome to the Safe System Audit course. And my name's Ken Beer. For those I don't know, I do know a few of you. And thanks to those who have been introducing themselves in the learning management system, which we'll cover off a little bit more shortly. I want to take this opportunity to acknowledge the traditional custodians of the varied lands on which this course is being run all across New Zealand. So we've got people logging in from right at the top to right down the bottom, which is wonderful. And yeah, you'll get an opportunity to introduce yourself a little bit more as we go along, and you'll have some discussions with different members of the group throughout some sessions we've got. We're going to cover off a little admin and logistics before we jump into some content. You would have seen Loretta there hit the record button. And the reason we hit the record button is, well, firstly, if you have to miss one of the sessions, you can catch up by watching the recording. Of course, we prefer you to be at the live sessions so you can interact, type in questions and the like, but we understand life is chaotic and things are unmovable sometimes. And we'll explain a little bit about your requirements under those scenarios shortly. I do give a content warning here. We show some road crash scenes, nothing overly graphic, but I just want to flag that now that that's something that could disturb you. Just be aware that we're trying to analyze what happened and what we can do to prevent it or lessen the harm that it's caused. So that's why we're using those. Now, who do we have here, Loretta?
That's me. So yeah, I'm Loretta Irados, the training coordinator here at Safe System Solutions, working in the training team along with Marissa, who you would have received a lot of emails from in order to be here today. But what I'll be doing sort of throughout the session is helping Ken in the background. We call that moderating. So any admin-based questions, anything about the learning management system, technical issues, etc. I'll try and help as best I can. Yeah, but if there's any follow-up, I'll ensure that we follow that up and someone will get back to you. But yeah, that's me. If you can't make a session, let us know. But I always say, like with Zoom, if you can't hear us, can't see us, something happens, log out, log back in. That's probably your best option. But otherwise, reach out to training@safesystemsolutions.com.au. And yeah, so in regards to the webinar, as Ken mentioned earlier, it is a webinar session, so we can't hear or see you, but you can raise your hand if you like. You can use the chat function, which some of you have already used. Thank you. And there is a Q&A function as well that you can send your questions through. But yeah, if you wanted to chat to everyone, there is, you select the little everyone there where the arrow is pointing. Otherwise, you can send your messages directly to myself and Ken, and we'll track that as well. But we do encourage you to, make comments and help each other out and engage as best you can.
Yeah, thanks, Loretta. And just reiterating that, because we're not all in the one room together and you don't get that networking at lunchtime and chatting with people, we sort of supplement that with the chat behind the scenes. So we do like you to chat to everybody and comment on things as they come up. Don't wait for me to say, does anybody have any questions? Because we'll have moved on by the time you type it and send it in. So as you think of it, type it in. Loretta will monitor the chat as I will be doing. And if we've already answered the question, we won't go back to it. But yeah, it's a good opportunity. Now, the raise your hand, yeah, we do have the ability to give you the option to talk. We don't actively sort of do that one from the start, just to stop all the dogs barking in the background and people forgetting to mute and then going off and getting a coffee and all of that sort of stuff. But do get into the chat. Now, these two people, one is me. My name's Ken Beer. I'm the principal engineer at Safe System Solutions, and I'll sort of explain a little bit about my background as we tick along, but you can certainly connect with me on LinkedIn if that's something you're on. That's a QR code there, or just search my name. And I share a lot of road safety engineering content, road design, auditing, and trying to save lives, prevent serious injuries through really good road design and management. This is my colleague Sam Paisley, who will join us later on in one of the modules, and he is Managing Director of New Zealand. And some of you know Sam. He's been around the road safety engineering space for a long time in New Zealand. His contact details are there. So he'll join us for a little bit of discussion later on in this. A couple of other people, Max McCardle, he's the Engineering Operations Manager. He will be jumping in for a session or two with some specialist content. And Fergus Tate, who, again, many of you will know, who has been around road safety in New Zealand for a very long time, and he will jump in and help out with one of the modules associated with design stage auditing. So, Loretta, learning management system. Explain what this thing is.
Learning management system is everything you need, I guess, for the course is in this system. So I guess if you haven't got access to the system, you need to reach out to us, but we did send the links through, but please let me know. I'll look into it immediately, because why? You can't pass the course without completing quizzes and assignments through this system. So it is very important that you ensure that you log on and familiarize yourself with the system. We'll go through it later. But yeah, that's the crux of it for now.
Yeah. Make sure if you haven't already accessed that, you dig out that email, or let Loretta and team know at training@safesystemsolutions.com.au. Okay, Wally the Wombat. Wally the Wombat appears a random number of times in every module, and you need to keep count. This is one of our little strategies to try to keep you engaged in the content rather than doing the emails and doing that roundabout design and that ministerial briefing and all of that stuff that's piling up. So keep an eye out for Wally. That's an example Wally there. Wally count is 0 at the moment, so that doesn't count. But yeah, keep an eye out, and then at the end of each module, you're asked a series of questions about the content, and one question will be, how many times did Wally appear? So keep an eye out for Wally. And another little strategy we have to try and keep you engaged, we will be giving prizes out. Loretta's in the prize pit there.
Yeah, funny background, but you won't get a Superman or Winnie the Pooh, but we will send you a little prize pack. I'll keep track in the background when Ken allocates the prizes, and I'll keep track of everyone who does win. And then at the end of the course, once you have completed successfully, we will send those through the post.
Yeah, and you get prizes by answering my questions and asking great questions, volunteering for case studies. And before each session, Loretta runs a little bit of trivia. It could be general knowledge trivia, could be road-related trivia, but that's sort of 3 minutes before the start of each session, a few trivia questions, just to give out a few prizes before we begin and incentivize you to log in early. So jump into those. And hopefully you got a little pack, a little welcome pack, and yeah, you see how we will get prizes to you at the end. All right, in order to successfully complete this course, we do have a competency benchmark we've required to make sure that everybody has that base level of competency in order for us to issue you a certificate of successful completion. So you need to come to 5 out of the 6 live webinars. So we've given you that one where if you just can't make it, that's okay, and you watch the recording and you do all the quizzes and everything. So if for some reason you can't attend more than that, just get in contact with Loretta at the Safe System Solutions email. Now you're going to need to complete all the tasks. We've got quizzes, exercises, assignments, reports, and 80%. 80% are pass mark. So it's pretty high, and we don't shy away from that. but the content is relatively straightforward. It's process content, and if you fail, I've failed, is what I always say. So I'm not going to let that happen. And the way I'm not going to let that happen is give you 3 attempts, but also give you one-on-one coaching if you are struggling. So all the stuff in the tests and the assignments and everything we will cover in the module. Then you'll have the access to one-on-one coaching if you still can't get your head around it, and you'll have up to 3 attempts. We certainly have, we really don't have people struggle to get through this course as long as they are paying attention and getting involved. Okay, so any questions you have on the admin, logistics, the running of the course, what we're doing, pop them into the chat as we go. Loretta and I will be monitoring that. I'm going to get onto some content, unless there's anything I need to cover off, Loretta. Looks like
No, all good. Kick off. Thank you.
Okay. Excellent. So safe system audits in New Zealand. It's a really exciting time in New Zealand with road safety auditing, safe system assessments, and the formation of safe system audits being a sort of combined version of those approaches. And I'm going to start from some very basic stuff, and then we will get a little bit more advanced as we go. But the first thing that's really important is that we're all on the same page with what this thing called the safe system is. And I know a lot of you have had this many times. You've heard the different presentations. You've read about the safe system. I'm going to maybe reiterate some of what you've heard, but also maybe just put a little bit of a different contextual lens on it. Now you need to remember that I'm an engineer. I'm a road designer and planner. So I operate at the practitioner technical end of the management, design, operation of the road system. So a lot of the time we have safe system being talked about by policymakers, high-level executives and the like, who are certainly committed to the approach and very committed to improving the lives of New Zealanders. However, haven't actually likely worked on road projects ever and been actually in there trying to apply the safe system on the ground. So that's where I come from, which may assist you a little bit in some of the work you're doing as well. Oh, there's a first little Wally. So Wally count is 1. That's all the help you get from me, but keep an eye out for little Wallies appearing around the screen. So let me take you back in time, at a point in time in New Zealand where the safe system was just emerging as something that that New Zealand was considering taking on. And in fact, I'll start that prize giving. Just type it into the chat. You don't lose any marks if you get it wrong or anything like that. Just type into the chat what year you think New Zealand formally adopted the safe system approach to road safety. So pop a few guesses in the chat there. Okay, Frank's first to guess, 2002. We got 10. Ooh, a lot of 10. We're jumping around. This is good. Now, good. Lots of interaction, and this is confirming that that everybody is able to use the chat. Now, this is where Loretta earns her keep. Loretta, the answer I'm going to use is 2004. So the first person to say that or the closest to it can be the prize winner. Now, there is always a little bit of debate around exactly when it was formally adopted, depending on exactly how you define that. But it's around that mark, 2004. So the safe system has been around in New Zealand and has been a commitment at a national level for a very long time, 20 years. It's been up and running. But really the actual adoption of the safe system and understanding of the safe system and application of the safe system has been a very long and arduous process. I was involved at an Austroads level, and New Zealand being an Austroads member, we had New Zealanders in the room, and we were trying to debate the adoption of this thing called the safe system, which was based on Vision Zero, sustainable safety out of Europe. And this is the diagram that in 2004 we were sort of looking at and developing. And you can see at the center of this diagram, human tolerance to physical force. And what an interesting starting point for the design, management, and operation of a road and street network. It is interesting. So how much force can the human body handle before it breaks? Then we looked at, okay, we've got these levers we can pull to improve the safety. We've got the vehicles that people are traveling in or on. We've got the roads and roadsides and how they're designed and managed. And then we've got the speed of travel and how fast all this happens. And then there was a circle drawn around that, and that was the safe system. That was it. That was what we were saying. And then in this boardroom, we had one group of people who are saying, hang on a second, surely we've forgotten a really critical pillar element of the safe system, which is the people. We have to have safe people. And this kind of divided the room. And we had half the room saying, yeah, well, that's critical. I mean, they are in control of the system. They're active users. We have to ensure that they act appropriately in order to get safe outcomes. And we had another side of the room saying, no, humans, they are just mistake-making things, mistakes all the time. And we see failures, we see risk-taking, we see just crazy activity all the time, right? For us to demand and require perfect behavior out of humans is ridiculous. No, we've got to create a system that is impenetrable to human behavior. And so the debate raged, and they put this alert and compliant road users as this sort of square around the system. Now, that was an interesting approach, and it was probably just a way to get this moving through. But really, it didn't last too many years because of that side of the way that ended up playing out was that every incident on the road, pretty much every incident on the road, it was just pointed back to that. Somebody was not alert and somebody wasn't compliant. That's it. And that is, I've done hundreds of fatal crash investigations in depth and serious injury investigations in depth. Every one of them, I can find somebody was not alert or compliant, and that could be used as the reason for that crash and the resulting death and serious injury. I mean, in order for a crash to happen, it has to have something that's gone wrong like that. Okay, very occasionally out there, we see some catastrophic vehicle malfunction or some absolute major road defect that really is this contributing cause. But that's very, very rare. It's humans stuffing up because that's what we do. You've made mistakes already this morning. I've made many mistakes already this morning, very minor little things, no doubt, and none of them have had major implications. But when you're operating a machine that has this high potential to kill or seriously injure and you make mistakes, unless your system is there to manage all of that, we see horrific consequences at very, very random, sporadic points. I'll delve into this a little bit more as we go, but I do welcome your questions and comments. And we're into, I'm talking very philosophical to start this. We'll hone it into road infrastructure design in the next, next few modules and things. But I need to have this sort of holistic understanding. You can't do a safe system assessment without understanding the principles here. Anyway, so that got thrown in the bin as a sort of conceptual diagram of the safe system. And then all sorts of different diagrams started emerging in the jurisdictions. Across Australia and New Zealand developed one, and then we saw different evolutions of it. Circles seemed to be the go. Everybody jumped on some sort of circular representation. You'll recognize some of the New Zealand ones there from different points in time. You had that one, you're on that one now. And let's just jump into one diagram here. And this is generally what New Zealand is adopting. I'm a little bit cagey in exactly what I say in that sense with your changing government and what they are currently endorsing and not endorsing. I'm not here to talk about your specific political framework that you're in at the moment and different operations politically. I will just talk to the principle of the safe system and how we apply it. I will happily sort of have some of that discussion later in the session when we do that, how we might navigate different governmental changes. Anyway, let's hone in on this. And it's a really elegant way to represent the safe system. And I think that a lot of credit to the New Zealanders. I actually run this course and similar courses across the world. And I do often use this diagram due to a few little specific elegant parts of it that I think the New Zealanders have really captured well. So at the center, we see there, we've got the vision, which is a New Zealand where no one is killed or seriously injured in road crashes. Important wording there. It doesn't say a New Zealand where there are no road crashes. And that's a very distinct choice to use these words, because we understand that crashes are going to continue to occur. Mistakes will continue to happen. It's about managing those mistakes. So yes, we want to stop crashes, but we just want to manage crashes when they do happen. Then we've got around the outside here, these important principles, the principles of the safe system. And you would have heard most of these, no doubt, but I will elaborate on a few of them with some specific stuff. We strengthen all parts of the transport system, the road transport system. I prefer road and street transport system. We're not just dealing with the arterial network and the national highway. We're dealing with streets as well, and paths, and all these bits we would call road or road-related areas. But we're thinking about all these elements of the system, and I'll talk a little bit more about that shortly. This is so hugely important. We design for human vulnerability. Now, engineers, road designers, street designers are just so comfortable with designing for specific criteria. Okay, we will design, drainage design for a particular flood level. We'll do lighting design. You do an intersection, it's got to meet a specific lighting level, and we'll meet that. And if we, it does not matter. We will meet that. We will make that happen, right? What we need to do is start getting ourselves in a mindset that the human tolerance to physical force is a design criteria, right? We've got to identify the crashes that could happen at this intersection. We've got to identify the energy that is tolerable by the human body, and we design for that. I'm going to elaborate on that with some actual figures and some specifics for you as we go, but that's a principle that we need to start to get in our mind. we've got a shared responsibility for improving road safety. Now that some people often say, oh, so that's saying that the road users have to act responsibly. The actual foundation of this principle is us. It's saying to us that it does not matter if the person didn't act appropriately, wasn't alert and compliant, whatever they did, okay, we still have a responsibility to analyze the system as a whole and understand what could we have done to intervene. We're going to try to get humans to be better and to behave better and to make less mistakes, right? But we need to just really understand that their mistakes, their violations, all of these things is our problem. And by us, I mean system designers. Our actions are grounded in evidence and evaluated. This is hugely important in road safety. The reason for that is that just a lot of people believe they have expertise in road safety. And that's because often that they have personal experience. They've driven for 40 years. They're an active cyclist. They're an active walker, or they have a particular special need. And by all means, we should be listening to these people and understanding what their desires are. But they are not experts in road safety. They are not basing things on actual evidence, evaluated, and understanding holistic studies, right? There are a lot of things in road safety that on their face value look like really good road safety initiatives. But when you actually evaluate them and read the comprehensive research that's been done on them and evaluations, they're not good at all. And yeah, if you're ever bored at a barbecue talking to somebody, just ask them their ideas on how we improve road safety. And they will have passionate ideas. Okay. I think that's great. I think people should do that. But we really need to come back to what is the evidence? What is the evidence? The other thing is you are not a statistical sample. You and your lived experience should not be making decisions about the application of safety interventions on our road. You, looking at evidence, research, evaluations, should be making decisions on the application of road infrastructure. Okay, let's give Max a prize just for fun. Our road safety actions support health, well-being, and livable places. Okay, so this is one of the ones that I take internationally and say this is very smart. Okay, road safety is a complex thing, and certainly we understand some of the challenges associated with deployment of different road safety interventions, and certainly, yes, political stuff, and we've got community and their opinions on things and the like. But if we can coattail on other community good, I absolutely think we should. And the reality is that in almost all circumstances, health, well-being, and livable places and road safety they're all one. They're all intertwined. You make your streets in a city healthier, more livable places, and the like, you will get safety outcomes, and like they work together. So if we can coattail on that, we're in a good place. We make safety a critical decision-making priority. All right. This is where we say safety is paramount. Safety is number one. Now that is bandied around as a statement, just willy-nilly. Oh, safety is number one, and workplace safety is number one, and the like. In the road and street space, there is more of this balancing out, just an appropriate number of our community killed and seriously injured in order to achieve other objectives. And we're trying to challenge that. Okay. Yeah, we understand we have a transport network that needs to move people and goods around. Okay. But we've got to challenge the acceptance of, in order to do that, we've got to kill, that many of our community. And we promote good choices, but plan for mistakes. So we will continue to do work to try to promote better driving, better riding, better walking, better choices out there from humans, right? So it's not going to stop the education, the enforcement, the encouragement. But we need to get ourselves in the space that, we're going to continue to do that, but people are going to make mistakes. And we need to plan, design, and manage for those mistakes. Now, Loretta, I'll take questions in a second if anything's popped up. I saw a few things pop in there. And no, but yeah, actually, maybe I'll take that now if there was anything.
Yeah, there was just one thing that came through actually. The question or comment was, the concept of shared responsibility in safe system is misunderstood, or any evidence-based study on that rather than some discussion?
I agree, absolutely, and prize for identifying that sort of misunderstanding of shared responsibility. In terms of evidence-based studies, I can't point at anything. It's one of those ones where it's more a philosophical concept, and so it's hard to sort of get that particular study of it. But what I would point you at is the Australasian College of Road Safety, which has a New Zealand chapter, and some of you might have been to their seminars. The Australasian College of Road Safety has a policy statement. It's recently been released, which really gets into this misunderstanding of shared responsibility, and really questions whether it even should be mentioned in the safe system definitions, for the exact reason that that's being pointed out here, which is the misunderstanding. I think if people actually understood it, as I sort of explained, which is to say that we can't just point responsibility to individual road users. We need to, as system designers, take the ultimate responsibility, then I think we'd be okay. But I think it's just misinterpreted to that blame game again, just saying, well, we did our job. We designed a road that if you use it properly, you'll survive. And yeah, that's that sort of misunderstanding.
Thank you. We've got one more.
Yep.
So if human responsibility is important, then shouldn't the promotion of safe driving should be at a higher priority? If do so, this could be a cost-effective method.
So, okay, there might be a little bit of a misinterpretation of what I've been saying. So I'm saying that we understand that human performance, we will continue to try to do things to improve that, but there are significant limitations with the ability to make humans perform perfectly 100% of the time. Like we can't do that. And so in driving or riding or walking behavior improvement, there is just significant limitations. And actually, I'd go almost the opposite to the comment that's come in there, in the sense that it is probably the least cost-effective thing for us to do is try to make humans better. And it is the least sustainable. Like, as in, new ones of these humans just keep coming into the system and they need all of that investment again. But if you transform the infrastructure or the full vehicle fleet, or the vehicle fleet's a little different. It keeps new vehicles keep coming in, but they generally are the optimal safety, whereas humans come in at all sorts of weird positions in terms of their abilities and the like. It's the least cost effective, the least sustainable, and to a degree, the least effective. Doesn't mean we're going to ignore it, but you're trying to just get a set of bench line of behavioral change initiative. I'll explain this a little bit more shortly in a little bit more detail. It's a very good, it's a good question and a good comment, and it's stuff that we really want to get our head around a little bit before we jump into actually doing these safe system assessments. Okay, I'm going to talk about safety culture because the safe system is a safety culture way of thinking. But let's go out of roads and streets and we'll jump into the manufacture of widgets of some description, widget production in a factory. And you can see there back in the day, it was a fairly open system in the sense that we had workers in there, and then we had, some kids going and clean maybe, and others getting involved in different things. And we had a lot of sort of death and serious injury associated with the production of, in manufacturing. And everybody knew it was dangerous in factories. And the factory owners and managers would tell people and explain to them how to do things safely, and then say, right, now you've been told how to do it. It is up to you to protect yourself. So pushing safety responsibility to an individual in an unsafe environment is what we call a pathological safety culture. As we elevate our safety culture up, we go to a reactive safety culture. So that machine that's ripped the arms off 3 people or killed or crushed people, that machine then gets analyzed and people make alterations to the machine to try to lessen the chance of that happening in the future. So you address problems as they come along. That's reactive safety culture. Then we go and elevate to a calculating safety culture. This is where the economists usually get involved, and somebody analyzes the whole factory or all of the factories in that management of, or that company's management, and say, well, if we actually put guards on all of these machines, it will reduce the number of people that are killed and the number of people that are seriously injured. And those injuries and deaths are actually costing us money because we have to shut down the factory while we pull their body parts out of the machine. We have to give some money to the family because that's their breadwinner that they've lost. And there's lots of costs to us. So it's actually worth it to invest a little bit. And so they've come up with a benefit cost ratio, which is, the amount of dollars we're going to make because we put these safety initiatives in place. And, off they go and they say, maybe, we'll invest £30,000. It was pounds back in these days. And we'll get £90,000 return over the next 10 years and makes it a benefit cost ratio of 3. So then you elevate from that and you go to this proactive safety culture. And this is where the safe system sits. And it says, we need a very high level of safety, very high level of safety. And we will produce widgets within the envelope of that. If we exceed that envelope of safety, widget production will stop until we get back into that safe envelope. So actually safety sets a precondition for the production of widgets. And then you have to maintain that. Once you've got a proactive safety culture, you need to continually invest in maintaining not just the equipment and infrastructure and the like. You need to continue to maintain that culture of safety. So when we look at the New Zealand road network, the management, the design, and everything of the New Zealand road network, we see it sits across a number of these sort of safety culture ladder positions. Absolutely, there's pathological safety culture in there. We give licenses to young drivers. We tell them how dangerous it is out there, and we push responsibility for their safety to them, and then hand them a license and access to a deadly weapon. We are reactive in the sense that we do identify problems and we go and address those black spots, areas of high crashes, crash reduction studies, and the like. And calculating is very, very big in the sense that the transport economists will work very hard to optimize the exact sort of acceptance of how many New Zealanders should be killed and should be seriously injured in order to ensure travel times and other sort of objectives. We do have proactive, and proactive, there's more and more of it coming along, and this is great as the safe system starts to filter its way onto the New Zealand road network, and we see things like new roads having continuous barrier systems along them. I was having a look at the Waikato Expressway not too long ago, and I think looking back even 10 years ago, probably even let's go 10 years ago, it certainly would have been designed and built in a very different manner. It would have been it would have not had continuous barrier systems. It would have been sort of clear zones and wait and see where clusters of crashes appear, and then you might put some barrier. But no, they went with the proactive approach of saying, no, we put continuous barrier systems through that. So that's a good example. I think school speed zones have been one of the earliest examples of proactive. Now, I know there's a lot of sort of work happening in New Zealand to try to get school speed zones even further down from 40s to 30s, and that'll be good to see that play out. But even if you just sort of take the 40, if you do a traditional transport economic calculation on school speed zones, they're a horrible investment under a traditional economic analysis. They're just woeful. You'd never invest in school speed zones. And in fact, under our traditional transport calculation models, you get a whoppingly high BCR by removing all your school speed zones. And the reason for that is to a degree, I would say, archaic nature of transport economics. But the reason for that is that if you take all the school speed zones in New Zealand and you calculate the amount of time it costs for each driver that goes through there, it might be 3 or 4 seconds or 7 or 10 seconds or maybe a little bit more per vehicle. But you multiply that by all the vehicles that are going through all the school speed zones, right? Then you take that, becomes collectively a big amount of time, and you multiply that by the standard productivity of a New Zealander, $88 an hour or something around that, and you get this dollar value of the cost, right, of school speed zones. Okay, there's signs and things that are also a cost as such, but that's minuscule compared to what ends up being that productivity one. Then you go and you say, well, what's the benefit? What benefit do we get out of these? And under transport economics, your benefit comes down to put a dollar value to a kid's life or anybody in those school speed zones' life, and work out how many of those you save. And you work out, well, what are the saving of death and serious injury? And the saving is very low. In terms of the dollar figure, because of the dollar value that is put to human life and the number you save as a result of these initiatives. But, that's so sort of grotesque a way of doing things, like that you would actually say, no, it actually makes economic sense to kill a few kids and seriously injure a few kids across New Zealand because we can get a little bit more a little bit more travel time savings for drivers. Like, yeah, so we can see that proactive, safe system, like from a philosophical sense, actually works in those situations. Kids hold that special place that we're willing to actually put safety first. For some reason, the general public don't usually get afforded as the same philosophical way of thinking as we do for kids. Anyway, that's yeah, a little bit about safety culture. And as I mentioned, I'm talking very philosophical at the moment before we delve into some specifics. Loretta, let's see. I saw things coming in.
Yeah, lots of good comments and interaction with the participants, so thank you. But I guess the one thing that sort of kicked off a lot of comments from everyone was from someone that said, is there a threshold of safety? You can't guard against 100%, so practically how do you choose how far you go? So there was quite a lot of comments after that, which is great. A lot of yeah, points being made there. Did you want to comment on that?
It is a really good point. Give that person a prize, because that we need to understand that, and that is probably one of the things where, you know, when you're actually in there on the ground doing work, it becomes very challenging. What I would say, I'm not going to give the absolute specific answer to that. It is simply to say that road and street transport, if we could get our risk levels proportionate to any other form of transport, then we would be in a position where we're sort of genuinely at that safe system level. And by that, I mean aviation, shipping, rail, like moving people and goods can be done at like an absolute, like, the risk profile on roads and streets is astronomical compared to any other form of transport. And people jump up and down and say, well, that's because it's an open system. Like, people, you know, everybody's, you can't control these people. Like, planes have a pilot, and you know, trains, you know, have drivers and everybody. Well, the thing is that a lot of systems were originally like that. Take our widget production. I mean, it was pretty much like that. Now people then go, well, hang on, now it's a very coordinated system. Well, it is, but it took time and it was a dedicated effort. And yeah, it's very complex, but at a one level above that, it would simply be to say that we treat the road system like a workplace, and the way we look at death and serious injury and risk in the workplace as well. So whichever one of those resonates with you a bit more.
Thank you. Just another question that's come through as well. At what stage the proactive action is too much? The continued barrier system could create more road rage and driving in a cage.
Sorry, can you say that again?
Yep. At what stage the proactive action is too much? The continued barrier system would or could create more road rage and feeling like driving in a cage.
No, I don't. I don't agree with that. That specific example, that's certainly simply a product of having driven on a road network without barrier systems and protection, and not being used to that. Yeah, I mean, we've delved into a specific there, but that you know, around the world, those sort of things have been deployed, and people are fine with it. Good.
Thank you.
Great interaction. Great questions.
Yep. Thanks.
I do give everybody a little bit of a stretch break at a half time or so, but I'll keep going. And I'm going to give you a little quiz now. I'll talk generally about some principles of the safe system, and then So I've got a question in there. A poll's about to come up. I've got a question here on that. And then a question I haven't really asked anything about, but it'll be for you to have a guess. Now, you're not marked on these, right? Anything that happens during the live session, you're not marked on. You have a quiz after the live session you're marked on. But let's have a look at that. Hopefully it popped up on your screen. Have a go at answering that. And I've slightly changed the wording, particularly from the New Zealand Standard, to ensure that you're thinking about the principles here. Just 2 questions. We will have a bit more of a break shortly, so you'll be able to fill up your coffee or whatever then. Give it another 10 seconds, and then we'll have a look at that, and I'll do a little bit more talking before we have our break. Just reading back through some of the chat as we go, and it's really great debate and a lot of really good comments in there, a lot of good questions as well. And we really do promote people questioning the safe system and really delving into understanding, well, why are we doing that? Is it appropriate? How does that play out? A really good comment in there around sort of why you would aim at 0, and I think that's an important one. I'm currently in the depths of an Austroads project, which is charting a path to the elimination of death and serious injury on the roads. And we, exactly as the comment said there, it's an attitude, it's a mindset, a philosophy that you really have to say 0 is our objective, okay? And we're going to work towards that. And decisions made along the way have to have a philosophical sort of stance of we're aiming to eliminate death and serious injury, okay? We're not going to get there in the next 5 years or 10 years or the like. But if you're thinking about each decision, not just as, well, we'll trade off a little bit, we'll get a little bit of improvement here, but actually trying to eliminate, your mindset sort of shifts a bit, which is good. And I'll give you actual practical examples of that with road infrastructure and the management of streets and roads shortly. All right, let's end that poll and we'll have a look, share the results. All right. Well, most of you are on this and saying no mistakes on the road. So it's not really a principle of the safe system to say we're not going to have anybody make any mistakes, because we're realistic. We understand it's still humans operating the road network and being involved in that. And we cannot eliminate mistakes out of humans. We're going to try to minimize and manage. All right, minimize and manage. That's what I want you to remember. We're not going to ignore trying to get better performance out of humans, but we just need to understand the limitations of that. And then our next one, Usain Bolt. Interesting one. What speed was Usain Bolt traveling? Some of you probably doing back of envelope calculations. 100 meters, about 10 seconds. What's that? But did you account for the fact that he had to accelerate? And the answer is about 44 kilometers an hour. So well done to those who picked that. Let's stop sharing that and get rid of it. And why am I asking about Usain Bolt? Why on earth? Well, let's have a look at somebody running, slower than Usain Bolt, definitely. But let's have a look here. Running along and, running into something solid. Okay. So if we were to park a Toyota Hilux at the end of Usain Bolt's lane, and he ran along just like this guy and bang, slammed into that Toyota Hilux at 44 kilometers an hour, will he survive? Well, the answer is most likely yes. He'll probably injure himself, but all of our science knowledge, modeling and prediction says that he would recover over time to lead a normal, healthy life. And in fact, humans in general have tolerance to physical force proportionate to their maximum running speeds running into solid stuff. You can test that yourself by running as fast as you can at a tree, and all theory says you will survive. Maximum running speed, hit that tree. You'll probably knock yourself out, break some bones, but you should recover to lead a normal, healthy life. That is how we evolved. That is our structure. That is our tolerance to physical force. Now, we have that information for different crash scenarios where there have been macro studies of humans being struck by vehicles, in this case, by passenger vehicles. And we see it plots out that the chance of death is, you can see here, 10, 20, 30 kilometers an hour is sort of the point where things start to go really bad really quickly. Now, Usain Bolt comes in up here, but remember, he's like the Hulk of a human. So this line represents all humans in a community, in the sense of we've got people, very frail old people. We've got young people. We've got people who are tolerating, big forces. And we get, you can see that. So vehicles hitting people at all these different speeds, and that's the general curve that comes out for our community. We have this for side impact crashes. So this we call the bullet vehicle in a crash scenario. The bullet vehicle striking the target vehicle here in a right angle crash. Target vehicle occupants are going to be the ones that are going to be killed. And we see sort of 30, 40, even 50 kilometers an hour before it starts to really go really bad, really quickly. And we have this for head-on crashes, which is the speed of each vehicle. So you would talk so when I talk about 70 kilometers per hour here, that's 70 and that's 70, right? So you technically have a closing speed of 140 kilometers an hour. But assuming that they're both the same mass and they hit each other head on like this, we think about the forces imparted on the individual occupants of the vehicles. So under that scenario, it's a 70 kilometer per hour crash where the human comes in at 70 kilometers an hour and crush and stops. Okay, so it's the same forces as running into a brick wall at 70 kilometers per hour. There's a good Mythbusters episode on that you could watch, which crashes cars into each other and then into brick walls with accelerometers, and just confirms exactly what I'm saying there. Because there were some people saying, well, the energy of the other vehicles pushing into them. Anyway. Throughout the course, if you download the PDFs, you'll get these hyperlinks to safe system snippets. And we just take, some of these topics we've expanded a little bit on and provided a little more information on our website, and you're able to have a look at that. And there's some videos sometimes. Okay. So in a safe system assessment, we'll take questions in a second. In a safe system assessment, we're going to use the biomechanics of injury. And what I've just been talking about there is the biomechanics of injury. We're talking about speeds, we're talking about angles, we're talking about different energy absorbing characteristics. And we need to actually score. We need to score the expected outcome of a crash scenario that we've predicted. So we can look at a bit of road and predict a crash is going to happen and say, okay, let's estimate how bad this is going to be. And we do that from speed, crash type, road users involved, angles. And we will, this is a little spoiler alert, we will be putting numbers to this between 0 and 4. And we'll be able to see, we've given some more crash types, and you'll be able to start to say, well, okay, cyclists getting struck by a vehicle, well, up here at 80 kilometers an hour, it's very, very bad. Okay. Down here at 10 kilometers an hour, it's much, much, much better. And you get a little bit of an indication there. We're going to take our break shortly. I'm going to give you a little exercise to do over your break. Actually, before I jump into this traditional thinking, and this diagram is the bane of my existence, by the way. I'm so sick of it appearing in people's presentations and them talking about, yeah, well, I'll explain that shortly. Let's see if Loretta has anything that I need to cover.
I think we are all good. It's just in regards to the green line. The green line for the person.
Yeah.
Did we cover that? So I assume it's an adult and children would be lower. The green line diagram, the speed of the vehicle. Yeah.
I know the one we're talking about. I'm not going to go back because there's too many wallies and it'll just blow people's mind. I'm just going to draw it here. So this was the one for vehicle hitting a pedestrian, right? This is for the entire community. Old people, young people, doesn't matter, right? So what the actual study was, thousands and thousands of crashes that sort of, all over the place, right? That is the general trend line you'll see, okay? And that's the trend line that came out of it. So yes, you might have like down here, like an old person killed, or well, sorry, maybe it's up here, like an old person killed in a crash that's like 5 kilometers an hour in a car park, struck, killed. You might have these freak incidents on a motorway where somebody's hit at 100 kilometers an hour. They're a young, fit person. Make them intoxicated because that actually means they're more likely to survive to a degree. They're far, far, far more likely to be involved in crashes, but it actually gives them a little bit of ability to survive a little bit more in a weird kind of way. Those things happen. They're freak rare incidents. But the general curve we see for our community goes like that. Okay, good question. Thank you. Give that person a prize. I like clarification questions because I want everybody to be on understanding this. Okay. Sorry, Loretta, is there something else?
It's, I guess, sort of on the same lines. What if car A is doing 100 in the head-on situation? What happens to the driver in car B if they're only doing 70?
Well, go back to your year 11 physics. Yes, so you actually, what we're looking at is, I'm going to pop it up here, delta V. Delta V is critical. So the change in velocity is critical. So you simply work out your altered speed based on delta V, and then that the forces on the individual occupant is what we're interested in. So like if hypothetically here, if you had a tiny little smart car coming in at 70 and you had a massive B double coming in at 70 and the B double pushed the smart car back at 70 kilometers an hour, that's 140 kilometers per hour of force on the smart car occupant, the little tiny car occupant. And the B double's got no force imparted on it. Now, I mean, there's tiny little bits of force, but anyway, yeah. So that's the general thing. Okay, let's go to this thing. And so this diagram appears a lot, and it is, as I said, the bane of my existence, not because it's wrong. Okay. The diagram is the culmination of a crash causation study. So this was a 2003 one. There has been like a dozen of these over the last 50 years, massive, comprehensive crash causation studies. What they do is they take thousands of road crashes and they really get into root cause analysis and understand, what's happened here? Why has this crash happened? What's the failure mechanism? And inevitably, they come out with the road user as 90 to 95% of crash causation. So this one happened to be just drivers, but some of these have been, other road users as well. The road sort of played this contributing role in some of the crash causation, the vehicle a little bit, vehicle malfunction, but very small. I don't dispute it. Like, absolutely impeccable research by just incredibly smart people. Why this diagram absolutely infuriates me is because of what people then take from this. And they say, well, the driver's 94% of the cause of crashes. We need to fix the driver. That's, we found the biggest problem. Let's fix it. What we need to understand is that crash causation is not what we are looking at solely. We need to understand, okay, crashes are still going to happen. What's the outcome? Why is our system not protected? You look at workplace, individual behavioral deficiencies, mistakes, and the like. It is also 90 to 94% of causation of incidents, but they don't accept that from a system perspective. They say, why did you have a system operating that when that mistake happened, which is obvious, they're going to make mistakes. They're working a shift. Like, why was your system not going to shut down, not going to change? Why didn't you have a guard? All of those sorts of questions come into play. So we need to say, yeah, of course, humans are going to be 94% of crash causation. Our system needs to pick that up. So this is an Ostro's diagram. They had inexperienced driver excess with a little bit of outside to say that, those are outside of system boundaries, outside of what is expected. So if you have drivers, driving 200 kilometers an hour down the wrong way of the motorway, like that's driver excess, and that's not within our system. Debatable, as in you'd say, well, we've got a whole system we can work with here. The vehicle, why on earth would it let the vehicle? Why on earth could it go 200 kilometers an hour? And secondly, why hasn't it shut itself down when it's going the wrong way down a motorway? Those are fair questions to ask. And driver inexperience is really people who have not entered the system in a way that they have basic skills and understanding of how to use the road system. But I won't get into that debate. What I just want you to remember is let's talk about altering our system as a whole. And another thing about errors in the road transport system is that people get fixated on this one, and probably the media has absolutely driven this, which is deliberate violations. People actually going out there to hoon, to be the boy racers, to they're iced up, and they're doing deliberate violations. But actually, errors come in all forms: slips, lapses, mistakes, unintentional violations. And what we know is that in New Zealand, somewhere around 70% of death and serious injury sits above this line, and about 30% sits in that line. So the bulk of our death and serious injury is people generally trying to go about things in the right way. Now, this was a Centre for Automotive Safety Research study across Australia and New Zealand. There's very specific definitions of exactly how they landed where the line is in itself. But the general principle is that, don't be fooled into thinking our road transport, the death and serious injuries to our community as all these deliberate violators. That's a massive portion, don't get me wrong. But actually, it's a lot more is just people going about their general daily business in one form or another. Okay, time for you to do a little something. Now, this is where you're going to get a chance to have a stretch and fill your water up, but you're also going to have a little go at this activity. Remember, you're not being marked on it, but this shortly a poll will pop up, and you're just going to say, okay, the traditional approach to road safety is here, and the safe system approach is here. And instead of victim blaming, where we say, well, no, you should have not fallen asleep, or you should have been concentrating, or you shouldn't have missed that stop sign. We were trying to move to another way of thinking, one of these ones. So you just link the two up. As I say, have a go at it. Don't get too stressed about it, because some of them could go to multiple spots, but it's a way to consolidate our thinking. I'm going to give you 4 minutes to do that, but also have a stretch, fill your coffee up. The poll's popped up on screen. Have a go at that. I'll read the questions and address anything that's come up, but back in 4 minutes. Right, let's end that poll and see, most people have had a good go at it, and I might actually stop sharing that. I'll just display it on screen. I've had a quick flick through. Most people have had a good go at it. And let's just have a look on the screen here. So we're really trying to, instead of look for that particular crash causation, not to say we're going to ignore that, but really understanding that humans make mistakes, and we've got to try and manage the consequence of these mistakes. We've got to try and minimize the mistake making, but understand that. There used to be this sort of focus on education and compliance. We're not going to ignore that, but really understanding the holistic system and a forgiving system. And what that means is that, when mistakes happen, it's forgiving of, it's not, the forces will not be so much that it'll kill and seriously injure people. So that focus on reducing crashes to that enhanced focus on the consequence of the crash. 4 pillars sort of action independently: the roads, the speeds, the vehicles, the people. Well, now it's this sort of multifaceted system, interacting elements, and mobility safety balance, saying, well, in the past it was what's the appropriate balance between moving people and killing our community and seriously injuring our community, to saying, no, actually, we've got to get safe, and then we'll move around as much as we can within that envelope. Let's talk about infrastructure now a little bit. Here's a central barrier system in a narrow flushed median. It's a wire rope barrier system. And this is a fairly recent job, well, to a degree. And it used to be a 100km/h road with a centre line, and there's a little bit more of it. You can see sort of barriers on there, bit on the good bit on the outside, but barrier down the middle. Now, without knowing much about this road at all, I want you to type into the chat some of the challenges that you think the team doing the planning, design of this, and getting the funding and doing the design work and doing all the stakeholder engagement and getting this project off the ground. What are some of the challenges they face with just wanting to put this barrier down the middle of the road? So pop them into the chat, and let's see what we're saying. Okay. Oh wow, this group is good, Loretta. It's like they've tried to do one of these jobs in the past. Okay. here we go. So we've got the different, just the general geometry and those sorts of constraints. So Ashley's jumped in there with maintenance, and then maintenance is an interesting one. Like in terms of, well, the barrier system is going to get hit and it's going to need to be maintained, but also like if you get potholes or you need to do resurfacing works or the like, how do you manage traffic around that? So let's give Ashley a prize for that one because there's a little bit packed into that. Land acquisition, road width's a good one. Road space, so Juliet's on that as well. Hello, Juliet. Turn restrictions from Max there. Yeah, so how do people get in and out of their properties if they want to go the direction the other way? They have to go down the road and turn around. Motorcycles and the perception of safety, another good one there. Road width, 3CL, yep. Carriageway width, this is, justification of the whole, investment. Are there enough people killed or seriously injured here? Are there enough head-on crashes to actually justify this? So that's a question that really goes a bit to the core of Safe System as well, where we're trying to say, well, no, only if that it's an exceedingly high number of our community killed is it warranting an actual safe system. Environmental is a good one as well. Ian can have a prize for that. Just the different fauna and flora challenges. So yes, any sort of removal of vegetation or anything like that, but also people get concerned about wildlife being able to cross the road and getting stuck and those sorts of things. With some more technical ones. So we've got drainage challenges. General public opinion, pedestrians being able to cross if they're in the area, deflection of the barrier system. This barrier system will technically deflect a little bit into the oncoming lane if struck by a vehicle. Now, well done to everybody on that. There's so many good comments coming in there, and it really shows you that to change our road system and our street system from what it's been for many decades, there's a lot of things that we have to sort of work through and think about. I just saw emergency vehicles pop up. That's another one that came up. All of these things absolutely came up, and they were concerns that people had about the installation of this barrier system down the middle of the road. This barrier system down the middle of the road will have hugely significant improvements in road safety. Massive improvement in road safety. Okay? But it comes with a lot of these little things to work through. Now, I say little things. These are pretty big things for individual stakeholders sometimes. So we don't ever want to like dismiss those, but we need to remember the value that this creates, this project. And the reason I bring this up is that in the past, we really only had a tool which was a road safety audit, which a lot of you are aware of. But a road safety audit would happen in the early stages of this job, and it would say, hey, we're planning to put this barrier down the middle of the road. Tell us what the risks are. And the road safety audit team would come along and they would say a whole lot of things, just like you've said there. They would mention lots of those things. They'd talk about some, technical aspects of it. And what would come back is a report that just has risk after risk after risk after risk. Okay, that's their job. That's what their mandate was. Tell us all the risks. But that can give an impression that this is a highly risky job to do. And we saw a lot of times that road safety audits would actually diminish the ability for us to actually get fundamental changes to our road transport system. But a safe system assessment, right, that was a process that would actually quantify the benefits of a job like this, and then also make a bit of commentary around some of those things that still need to be worked on. But it really clearly said, this is going to be very beneficial for these road users and reduce this trauma, and these are some things to work on. So we then had these two different assessment methodologies out there. And New Zealand, in a really bold move, has stepped forward and said, hey, we can combine these. So Austroads still sort of has two methods, and a lot of other, well, the Australian jurisdictions are doing both of these. But New Zealand said, no, we can combine these. And we'll start with that safe system assessment methodology. And then we'll look into the auditing into the details. But we want clearly upfront to understand how beneficial is this going to be overall in us getting that sort of safe system philosophy on the ground and the big reduction in trauma that will come with it. And then what are some of our technical specific challenges to work through? Now, of course, it got hit, and as barrier systems do, they're out there to be hit if they need to be hit. This one got hit, and one of the drivers involved in this strike of the barrier system called up the regional office and said, hey, I want to talk to the person who put that barrier system in. And certainly if you've ever been in that situation, you're answering the phone and you think, I'm going to get shouted at here. But they actually just wanted to thank them and say, hey, I think the barrier you put in just saved my life. And that engineer was smart enough, it wasn't me, it was smart enough to get the comms team and say, hey, I think you should have a chat with this person. And they created a little video. Now, we put the little video into the learning management system, and Loretta will show you that at the end. But I want you to watch that video because for me, it's a real safe system in action. It's just basically somebody fell asleep. They drifted into the barrier system. Otherwise, they would have drifted straight into another vehicle, and the barrier system just did its job. Otherwise, we would be pointing our finger at, well, traditionally, we would be pointing our finger at the person, oh, you shouldn't have driven tired, and oh, we need to educate people on fatigue management and all of that. But rather, the system just kicks in, it minimizes it. Not to say we don't need to continue to work on fatigue management and all of that. I'm just saying you can see where the system just intervened and made it so it's just property damage. I just want to jump in on a few of these specific areas, and these are the elements of the system, the levers, we could call them, of ways that we can achieve our safe system principles through either infrastructure improvement and speed management, vehicle safety interventions, system management, and the way the system is governed and decisions are made. We still have road user choices and that effort to create the best road users we possibly can, understanding the limitations of humans, and work-related road safety. That one's a good one. They're all good, but that one's got a bit of genius to it and actually defining it in there. Another one I use internationally because for some reason we've evolved, as I showed with my widget, the workplace death and serious injury is unacceptable. The roads and streets, apparently it continues to be acceptable. So in the genius of the New Zealanders here, they said, well, hang on a second, like there's a huge amount of travel on our road network that's actually work-related. So surely that's work-related road safety. Like we can actually leverage off that. So I think there's so much opportunity there. I'm going to start just very briefly talking about vehicles and vehicle safety. And I'm not going to spend long on this because we will, like in a safe system assessment, which is the purpose of this course to get into that safe system assessing, we do a little bit of a look at what is the vehicle fleet, what's out there. But yeah, we don't often within a project have much control over the vehicle fleet. But what we're understanding at a macro level, like at a big picture level, is what is the vehicle fleet of New Zealand at the moment? What are the safety features? What are the characteristics of the vehicle fleet? And what happens to that over the next 10 years, next 30 years, next 50 years? And what can we do with our infrastructure to A, make the most of the safety features that exist and are going to exist, and B, not waste our money with infrastructure that the vehicles will solve those problems? So under really sort of Vision Zero modeling approaches, what you do is you start to understand what are the vehicle features that are coming. How long does it take to turn over the whole New Zealand fleet of vehicles, or 95% of it, 98% of it? And then what crashes are being solved by the vehicles of the future? What crashes are not being solved by the vehicles of the future, and we need other interventions to step in? And what happens in that interim? Now, the limitations of the vehicles are still, quite big from a crash energy absorption perspective. So here we see a Toyota Camry being crash tested under the ANCAP protocol. Now that crash happens at 60 kilometers an hour. And, the occupant there has to not sustain essentially a high level serious injury they're going to hold for the rest of their life. They're like basically an acquired brain injury. So 60 kilometers an hour, it's not hugely fast. If we look at side impact pole crashes, so same thing, you slide the vehicle in at a certain speed, and you got to make sure that the dummy is not getting like an acquired brain injury, like lifelong debilitating injury. I'll give a prize for the person who can tell me what speed that crash happens. Remember, the other one was 60. So what side impact pole? Any guesses on that? So lots of good guesses. Lots of people wanting to go about 50. Well, they recently increased the speed from 29 kilometers an hour to 32 kilometers an hour for side impact pole tests. So basically, a 5-star vehicle can't guarantee the occupant they're not going to get an acquired brain injury if they side impacted in a pole above 32 kilometers an hour. That, like, the side of a car is not well engineered for energy absorption at all. The front is better. We've got crumple zones, airbags, seatbelts. They're all working on a frontal crash. The side of the vehicle, yeah, we've got a little side curtain airbag, but I really, really struggle to absorb that energy. 32 kilometers an hour is all. One of the great advancements in our testing and our understanding and our thinking about forces in crash scenarios is that even ANCAP said, well, we need to think about not just protecting the occupants of the vehicle, but protecting what we're going to hit. So pedestrians, cyclists, motorcyclists. So vulnerable road users are now included in that. And that's a 40 kilometer per hour strike. And thinking about, well, most new vehicles off the production line, either as you strike a pedestrian, the bonnet will pop up. So there's a cushioning effect, or you get an airbag that pops out over the bonnet. So, those features are starting to come into it. And that's a 40 kilometer per hour. So the question becomes, well, is it appropriate for us to just sort of sit on our hands and say, well, the cars are going to sort this out? The Teslas and, the Waymo vehicles, that'll all solve it. We don't need to actually do anything. And we'll get the vehicle with no steering wheel that just drives itself. Well, that under all sort of predictions so far, I can't get a straight answer really out of anybody on this. Nobody's willing to really be specific in the dates that they think that the bulk of the New Zealand fleet will actually be level 5 autonomy. But it's a long time away. It's a long time away. Just the sheer time it takes to turn over the fleet in New Zealand is big. It's one of the you have a very old fleet. I forget exactly what it is, 16-year turnover or something like that. The second one is just the technology. Like, we know that there are vehicles that pot around the foreshore by themselves, or you see videos of San Francisco taxis turning up with no driver and picking people up. Well, those at sort of best are level 4 automation. So there are 5 levels of autonomy. Level 5 is genuinely a car that can go everywhere that a cars currently can go and do it by themselves. Level 4 is where you geofence it and you particularly quarantine off what it can do, where it can go, and how it can go. Level 3 involves pretty much, what's in cars at the moment. The car's giving the drivers a bit of the impression they're driving, but the vehicle will take over in emergencies and when that decides it's appropriate. And level 2 and 1 have been around for a long time. So, we're going to see this infiltration in, but jurisdictions around the world continue to monitor and understand what is appropriate investment, as in, do we still get value in investing in infrastructure, safety improvements, in other initiatives, enforcement, in behavioral change initiatives and the like? Or should we just be pumping all our money into vehicles and just say, no, just buy everybody's vehicles off them and give them money to buy new vehicles and the like, in a very simplistic way. And the bulk of the time it does come out that infrastructure is still a really wonderful investment. Yes, you do want to do a lot in vehicle safety features as well and continue to provide a base level of improvement for behavior. But yeah, it's a long time off. But we will see a lot of benefits coming as we go. You can see here, vehicles sort of stopping by themselves when they see a pedestrian appear. And there's one where the legs come off. But that's a success, yes, in the sense that the vehicle, without human intervention, braked and then, yes, struck at lower speed. And we're managing energy in that sense. So we'll see a lot of that coming into play as we go. Loretta, I'll see if there's any questions shortly, but I'm going to just very briefly touch on a few more of these elements of the system and giving you that sort of high-level understanding. I need to talk about speed and the fundamentals of speed and speed management. And I'm really taking you to sort of road safety engineering 101, and it's around, speed. And the first thing I want to say is speed and so travel speed and impact speed are not a linear relationship. Let me explain what I mean by that. Okay, let's have a vehicle traveling at 60 kilometers an hour and a person steps out from behind a parked car 45 meters down the track. So we will see that there is reaction time here in the green. So that is the time it takes for the driver to see the person, to process that they have to do something in their mind, to lift their leg up, to put it on the brake. Then we have braking, and this is just your physics of braking. It's going to take into account the skid resistance of the surface. It's going to take into account whether it's wet or not and those sorts of things, and the braking characteristics of the vehicle. And what we see is that at 45 meters, they'll just touch that person. Let's go up now, 10 kilometers an hour. Okay, do they hit at 10 kilometers an hour then? No, they hit at 46 kilometers an hour. So it is not a linear relationship. So that's the first thing. The second thing is the integration of our crash curves into that. So the severity onto humans and a few other specific characteristics that lead us to understand that for fatal injury crashes, for fatal crashes, we see a fourth power relationship between travel speed and the chance of that death. Okay, so like a fourth power relationship means that, a small change in travel speed correlates out to a large change in the chance of death. It's a third power relationship for serious injuries. It's actually a second power relationship for all injury crashes. Okay, let me break that down a little bit for you, just in a simple soundbite, which is that speeds have the most influence on the highest severity crash types out there, and then they lessen down. And I popped this little meme thing up in on LinkedIn there a while back, but we're saying like small changes in travel speed can have a relatively large change in stopping distance. We saw that. It's not a linear relationship. So the impact speed then is much lower, and the impact energy is lower, and energy, your kinetic energy equations have lots of squared value in them. So we get this this very large change in the probability of death and serious injury from small changes in speed, which gives us great hope and opportunity. If we can get small reductions in speed, we actually see bigger results. And when we were updating the Austrade's Guide to Road Safety Part 3, which is speed and speed management, and I chucked in this diagram, which is a European diagram, but it really reinforces why speed is so critical to our transport system. If we understand the biomechanical limits of the human body, how much force we can handle, then you understand, well, what is the fleet we've got? What is the road infrastructure we've got? And what are the road users in terms of their energy absorbing characteristics and the like? And then you just filter it through the appropriate speed and you get a safe transport system. Speed is that governing force that we can use regardless of situation. But I don't want you to think that the safe system is all about just speed limit reductions and speed reductions, okay? It is applying the appropriate speed to what you have from a vehicle, roads, and road user perspective. Now, I would say that a racetrack is a fairly highly aligned safe system environment. It's got vehicles with really great safety features. We've got road users, wearing helmets a lot of the time and wearing their restraints and the like. And we've got roads and roadsides that have been designed for speed. And under those scenarios, speeds can be very high and we can still have a safe transport system. So it's about appropriate speeds for the roads and streets and what they have. I'll take questions after this, but we can achieve safe speeds through infrastructure and or speed limits. And where you're able to design a road that ensures people go slow, you're in a better scenario because more people comply with it. So local area traffic management features and the like are very effective in ensuring that speed. Speed limits are very, very impressive in terms of the ability to get general speeds down. And so they're hugely beneficial as well. Explaining why a speed limit is in place can increase acceptance and compliance. And protection of vulnerable road users is generally well accepted. And by vulnerable road users, I mean pedestrians, cyclists, predominantly. Motorcyclists, interesting. They are defined as a vulnerable road user, but they don't have as much general acceptance of a lower speed limit for motorcycle safety. We'll talk about that a little bit more later. But certainly pedestrian cyclists. And if you could take the other view of vulnerable, being kids, the elderly and the like, that also really enhances your acceptance of different speed interventions. Right, Loretta, anything pop up that I need to talk to now?
Yes, please. We've got a couple of questions that have come through. Just in regards to the stopping distance. So has the stopping distance reduced over time with vehicle technology enhancement?
So yes, yes, it has. So we're in a funny point in time here where we have, so those original braking distances and the like have come down because we've got better braking systems and better tires and better systems like that. Unfortunately, at a holistic level, the reaction time of humans seems to be increasing because there's far more exciting things to do in vehicles than watch the road, it appears. So we kind of balance the two off. Then overlay in that automation and auto emergency braking. And so we're getting some vehicles in the fleet now that are doing that job of looking for hazards and integrating some of the braking in. So it's this interesting mix. At the moment, we still stick with those sorts of that particular relationship, just for, well, lack of anybody doing a really comprehensive study on it, and the thought that it's sort of balancing and just reshifting. Good question. Thank you.
Okay, next one. The green part, so video previously, the green part is redundant as the car stopped on its own. Also, I question the orange bit in that Mercedes that stopped. It was hardly 5 meters.
That was in the video.
In the video, yeah.
Yeah,
a few slides ago.
Yep. No, I mean, there's a lot that was in that. We could talk to that for a long time, but I'm going to keep moving on unless there's something else.
Yeah, one more question. Should reduced speed and barrier system be used at the same time?
Yeah, great question. So I think holistically in the management of infrastructure and speed across the rural network, and we talk about rural network here, not the urban. The urban's got some very different characteristics. You want to ensure high travel speeds on major strategic corridors, and you need to do that through barrier systems, essentially. There is no other way at the moment that we can do that. So yeah, invest big on your major corridors and then reduce the speed on the other corridors. So be putting all your money, infrastructure money, into your major corridors, and you reduce the speed on the others. When you get those scenarios where you have little bits of barrier system, though, you're going to still need to bring speeds down because you've got too much crash potential for other crash types and in other locations along that route. So in some scenarios, yes, we will be doing infrastructure upgrades, but also reducing speeds, which we need to think about the messaging of that and how that is communicated to the public. Just another one on speed is that we are now able to be more dynamic with our speed limits and speed management in the sense of targeting speed reductions 2 times of risk. And New Zealand led the way really with the RIORs, the Rural Intersection Activated Warning Signs, or speed limit reductions. So you can see here the speed limit reduction triggering when there's a vehicle coming in from the side road, which you can see there. So we can be more advanced in this management. That's a point on the network. We know there's increased risk, but it's only there for a certain time. Let's target that. Great intervention. Strip shopping centers is another one. We can really do more there with targeting speed limit reductions during certain times of the day. And that's a good way for us to start getting people used to reducing speed where there's risk. Okay, I'm going to run through a few more slides quite quickly and then give Loretta time to show you your little quiz and the learning management system. I mentioned this briefly before. We're doing safe system assessments now. And a safe system assessment takes a road safety audit, which is Austroad's Guide to Road Safety Part 6, and the New Zealand old 2013 Guidelines on Road Safety Audit. So I was technical advisor to Austroads on that one. I had no involvement in that one whatsoever, but I do use it and read it. And the Safe System Assessment Framework, and combines the best parts of all of these into the Safe System Audit Guidelines. They are available online. Download a copy. We'll put it in the learning management system anyway, so you'll see that. So a safe system audit is a safe system assessment and a road safety audit combined, and you get a little bit of efficiency out of it. So the first common misunderstanding is that a safe system audit is a check against standards. It is not. Okay, you might be interested in standards and what's being achieved. But no, this is a fundamental look at the project to understand, or the existing road, what will cause death or serious injury to our community here. Doesn't matter if it meets standards or doesn't meet standards. What's going to kill and seriously injure our community? So it's not a standard check, okay? Even though it's called an audit as such, and if you think about financial audits and those sort of things, they're checking, did you comply with tax code and all of this sort of stuff? No, we're beyond that. Like we are, what is going to cause death and serious injury to our community? Here's a quick example. I mean, this was a death to a heavy vehicle driver. There's a barrier system in place. Everything met standards, but somebody was killed. The barrier system was a test level 3 barrier. It's only designed to really contain a small vehicle, about 2 tons, and it was never going to contain that vehicle. And so could we have thought about that more when we were doing the design? So there's an example of something met standards, but it resulted in death or serious injury. Here's another one. Meets standards to a degree, and this is what we call a trap lane. So they're building a new intersection here, and there's another intersection up here, and you can see a vehicle here driving along. Oh, I'm in a right turn lane. That's what we call a trap lane. Now we know we're going to get rear ends and sideswipe crashes here because vehicles driving along, they don't want to turn. They've just been trapped in that lane and they will get out of it. Now, this doesn't actually not meet standards as such, because it says we discourage trap lanes, but understands that they can happen. But again, our role is not to be concerned about does this meet standards or not. It's to say that's a potential issue. Because we only have a few minutes left, I'm going to jump over this little case study, and we will come back to it if we get time in the next session. It's a good one. And we're going to talk about slip-based poles as an intervention that manages energy. So that's where a vehicle strikes a pole and it shears at the base. And you can see one here from up New Plymouth Way, where it sheared off and it flew a long way. But that's a real example of thinking about the management of energy. So a vehicle hitting a rigid pole, all the energy is transferred to the occupant of the vehicle. A slip-based pole, it will shear off and the injury to the drivers is lessened. And there's a couple of types of impact absorbing poles there, and I've got some videos which I can show you later. Okay, a safe system assessment. I did jump through a section there, which as I say, I'll come back to if we get time. Safe system assessment and a road safety audit combined to this thing called the safe system audit. And it's a formal, robust technical assessment of a transport project where independent qualified teams audit and they consider the safety of all people. So that's pedestrian, cyclists, motorcyclists, people in wheelchairs, mobility devices, and e-scooters, and you name it. Everybody gets thought of. And we apply safe system principles in this assessment. And here we go. It's even stated directly in this. Not a review of compliance with standards. Now, we can do these safe system audits at various stages of a project. It could be before, they build anything. So it could be when they're designing something, planning something, thinking about something, concept stage, preliminary stage, or detailed stage. You can apply this process during construction, although there's some specific things in New Zealand that are other sort of ways people look at risk at construction sites. Or you can undertake this after it's been built, something's been built. The early stages, generally high-level plans, alignments, general information. Then the preliminary stage, we get more in the design. Detailed design, of course, we get a whole lot of technical information. And when you're doing safe system audits at this stage, you want to be in a team with people who can read this sort of information, really understand the technical detail. if you're not a technical, like have a lot of experience in this, you can still add value. In fact, sometimes you add wonderful value by just asking logical questions, where sometimes the detailed designers are so focused on this, specifics that they miss some of the big picture issues. Pre-opening stage is before the ribbon's cut on a job and you get out there and you check everything and make sure it's all there. And here you can see a post-opening. Post-opening is just after they finished their work, and this is they finished their work and they've packed up, and oh dear, we've got some line marking challenges there, don't we? And thematic audits. This is really where you take one road user group in particular, you integrate, you really hone in the specifics of that road user group. So a cyclist audit, you would ride the route and really focus on the cyclist aspects, pedestrian aspects, or motorcycle aspects, depending. Any safe system audit thinks about the safety of all these road users, but you can take one in particular and really hone in on it. Okay, I rushed a little at the end there because I need to give Loretta time to take you into the learning management system now. Jump in there, Loretta, and I'll just check the questions and see what I need to answer.
Thank you. I'll just share my screen there. Won't be a sec.
We've got your desktop.
Yep. Alrighty, this is the learning management system. So just to log in to the system. Oh, invalid. It's not invalid. Does that to me all the time. All right, so once you get to your dashboard, you'll see most likely one course, the course that you're doing today. In my case, I've got a few courses set up for, show and tell. So Safe System Audit New Zealand, February 2024. So click on View Course. And I know that some of you have already logged in, or most of you logged in and introduced yourself. So thank you. So basically, it's just sort of scrolling down the page and going through each module. So you've got your welcome page. That's where some of you have introduced yourselves. There's some resources, lots of different sort of fact sheets and documents that you can click on in here. And of course, we go through each module. So once sort of every module, you'll have access to every module sort of the day before. So today you've got access to module 1. There's a little video in there that you can view, but most importantly, you need to complete the quizzes and assignments, of course, as we go through. So today, module 1, there is a quiz. So clicking on the quiz and clicking on attempt quiz and simply answering all the questions. Till you finish the attempt and hopefully you can pass. So that's basically the learning management system, or LMS, as we like to abbreviate. If you have any questions, if you're struggling logging in, as we mentioned earlier, let us know at training email. But yeah, that's basically the learning management system. Did you want to add anything here, Ken?
Just to say that get the quizzes done. I mean, technically, you can do them at any point just before the end of the course, but it's good to get them done while it's fresh in your mind. And the resources there, you'll be able to watch that video I mentioned. It's in the resources there. Or is it in module 1 video?
I think it's in module 1,
Sorry.
that one.
Sorry.
Yeah.
Have a look at that video. I think it's really a powerful video from that sense of understanding what infrastructure can do to mitigate all of us human error. So a really wonderful group. Thank you so much for the interaction and everything that you've done there. Sorry I jumped a little fast at the end, but we'll pick up some of that stuff next module. Log in a little bit early before next module. Loretta will give out some prizes, bit of trivia, and we'll kick it off then. Thank you. Have a good day.
Thanks, everyone. Bye.